Hey, I wanted to make a video just as an update. Sorry, this place is an absolute disaster, but I wanted to make an update on using a inductive prox and a click PLC to see wheel speed on a car using an ABS tone ring. And I don't think you're going to be, yeah, you can see that there. So here you can see, and I had this in I did another video on this. I think I uploaded it. Maybe I didn't. But I've got a tone ring in there just on a basic spindle. I have a Automation Direct. I can't remember the exact brand, but I have a prox here. This is an 8mm inductive prox. The specs on it, it is 3K, so it is up to 3,000 pulses per second in theory. I'm not going to need anywhere near that, but that's its maximum capability. Just so you know, this prox was like 30 bucks. It wasn't very expensive. And I made a little bracket here for it. It's crude, but it's a steel bushing that goes inside here. I have a bronze bushing inside of that that's threaded and soldered. And then I welded this tab on, so it's all nice and solid. It doesn't move. It's pressed in there firm. And this is just a junkyard hub that I pulled off of an 86 Corvette, just to give you an idea. But you can see I've got the prox in there lined up on the teeth. You can see the light here on the prox, and as I turn the spindle, you can see that it's counting those teeth, right? So just so you're aware, this original setup used a reluctor, one of these sensors that was in there that uses reluctance to make a sine wave. This system with a prox is going to be purely digital. It's going to be square wave. So that's kind of the issue, is a lot of modern controllers want to see that square wave signal. And yes, you can adapt it, but the thing is, why, when you can take a cheap prox switch and do the same thing? Now, I have this being fed to a high-speed input on a PLC that will be going into my car. The whole purpose of this is so I have a computer that can see the difference between front and rear wheel speed. That way it knows if I lose traction. Then I can have it send a signal to my Holley ECU to make changes in the tune-up based on tire traction, okay? So I just wanted to show you what I'm doing. I have a very simple program, and I don't know how well this is gonna look, a camera pointing at a screen, but I have a very simple math formula in here. That DD1, that is the input from that prox sensor as frequency. That times 0.093, that's a variable that I put in to compensate for tire size, okay? This reluctor wheel has 47 teeth, so there's 47 teeth per single rotation. The tire on that car is 24.5 inches tall. So I did a little math to come up with this variable, this 0.093, and it saves it in this area called DS1, Data Store 1. I have this window pulled up. You can see DS1, I have it saved as miles per hour. Current value right now is 0. DD1, that's the frequency. That's going to count how many pulses there are. So what I'm going to do is I'm going to turn this by hand, and you can see as I turn it by hand, you can see the prox lighting up there, right? Let me turn this flashlight off. You can see this, I'm turning it real slow here, and you can see it counting each of those teeth. Now, as I put it here, watch the miles per hour. I'm turning it by hand, and you can see 5, 6, 7, I'm sorry, my hand's shaky. I got it up to 7, maybe 8 miles an hour. What I did before I started making this video is I took my impact and put it on here just to try to spin it as fast as my impact, and more importantly, my air compressor would allow it to spin. And I got it up to about 22 miles an hour just here on a workbench. The important thing is the PLC and the prox sensor never skipped a beat, at least up into that speed. This particular PLC is rated for 100,000 hertz with this card. Now, that doesn't mean 100,000 hertz on every input and it'll give that to you. With cheaper PLCs, the thing you have to understand is if I have two proxes sending 10,000 pulses a second each, I'm using up 20,000 pulses worth of input. Also, keep in mind that 100,000 is if there's nothing else going on in the program. That is an absolute best case scenario, and chances are you're probably not going to get it. At 150 miles an hour, This thing will put out 1,600 pulses a second. That will be its frequency. I will have two of these sensors, one on the front wheel, one on the back, feeding into high-speed inputs. So I'm not even using up 4,000 hertz worth of inputs into that processor, and I have a total of 6 high-speed inputs that I can use on this, and I'm only using 2. And it has a capability also to do high-speed outputs, and I'm not using any of those. So I think it will fairly accurately calculate wheel speed between front and rear, all for a real cheap setup. This is going to do a lot more for me too. This is going to control nitrous oxide and a bunch of other things in the car. But I just want to do a quick video showing, yes, you can calculate wheel speed. You can take in a sensor like this, convert it to whatever pulses out you wanted, and then you could even have this send DC pulses frequency output to things like a speedometer or whatever. You could actually use one of these to compensate for tire size if you wanted. You could take the input from the sensor. Sorry, I'm so filthy. You could take the sensor data into the PLC modify that data and put it out for things like VSS or whatever you needed. So anyway, that's it. Just my nerdy little video here for the day. This is a Click PLC from Automation Direct. Software is free right from Automation Direct, even if you don't want to buy the PLC. Check out their software if you're into programming PLCs. It's pretty much a knockoff of Allen Bradley. All right, thanks.